Virtualization. This is taking a physical computer and hosting artificial computers inside, simulated or virtual machines. Each virtual machine is in effect a computer in of itself. It has its own hardware, it has its memory, it has its CPU, it has its own operating system. It has all of this. Now the hardware is coming from the host computer, but it's simulated. It's telling it it has this CPU. It's telling it has this much memory. Now, the host system has to have at least that much memory, plus more to manage its own stuff. If you're running multiple virtual machines, that host machine has to have enough memory for all the virtual machines that will run simultaneously. But benefits include easier administration, greater efficiency, continuity of service. I think of a software developer. They're developing an application to run in Windows 7. It's going to run in 8. It's going to run in XP. Does that poor guy want 3 desktops or even 3 laptops on their desk? Even if they got small laptops like this, it's a pain. They may want just one machine with a bigger screen. And with that one machine, they could run virtual machines to have their XP, to have their Vista, to have their 7, to have their 8, all within this one machine. Now, I don't know what that one machine is going to be running. It could be running any of those so long as it can run the VM software. Now, virtualization levels, you can virtualize applications. Just host an application in a virtual machine. You can host a desktop. You can host servers. Hosting a desktop, this is where you have just a client machine. You can install applications on it. It runs just like any user's desktop. If you're hosting a server, it's just like hosting any other server. To the clients, it looks just like a real server with multiple power supplies and everything else, except it's hosted in a virtual environment. You don't see the difference. If you have to install a patch on the XP VM and you got XP 7, Vista, and 2000 all in that one box, and let's say the host is running server 2012 and you have to install a patch for XP, you go into the XP virtual machine and you install the patch only on that machine. If you have to reboot the XP virtual machine, it's the only one that reboots. Nothing else is affected. If it gets a virus, it's the only one that gets the virus. Nothing else gets it. Now, if the host machine should get a virus, probably only it's going to be affected. The virtual machines probably won't be affected, but if the host machine is affected enough, they may be impeded in their performance. They may even go down because the host machine goes down. Host machine is rebooted, all the virtual machines are effectively rebooted because the host machine went down. They're not up any longer. The hypervisor is the virtual machine manager. It keeps track of all the virtual machines. It allocates the resources to them. Each virtual machine gets so much memory. Each one gets so much hard drive space. It keeps the virtual machines separate from each other. They can't touch each other. They are completely apart. Now the hypervisor can be on the bare metal or it can be host-based. Now this exam is probably not going to look at the difference. Host-based might be run onto like server 2012, whereas bare metal would be running a base system with maybe some like VMware on it. Now, client virtualization allows standard installations, even on varying hardware. It doesn't matter if you've got an Asus, Acer, Lenovo, HP. Doesn't care what the brand is. Doesn't care if you set up a virtual machine. It's the same on every single machine. It's going to have the simulated hardware, which is identical. So it doesn't matter what your host is. Everything is the same. Easy backup. You can do a snapshot of that virtual machine, back it up, restore that snapshot. It's back exactly where it was before something went wrong, duplicate it to another machine, easy migration. End users can access the same VM from multiple physical clients, especially if you're hosting something like a virtual server. They can all connect into it and use it, just like they would any other server. Replaces multi-boot configurations for test machines. You know, instead of, okay, I'm running XP on this machine, let me reboot it and tell it to boot into 7 next time. That was a nightmare. And every so often, one operating system would override another and it wouldn't bring up the other ones any longer. Nope, you have truly separate machines stored within that one. Now, you can have all those virtual machines stored locally on your machine, or you can store the images up on a centralized server and pull them down and use them on an as-need basis. Now, the virtual desktop requirements, you have to have enough CPU for that virtual machine to run. Remember, if you want to run AeroGlass, you've got to have at least a 1 gigahertz processor. So you've got to set aside 1 gigahertz, how many cores, hardware-assisted virtualization technology. The CPU you have may make a difference. If you don't have a CPU that can support enough machines, you might not be able to effectively virtualize. You need sufficient memory for both the host machine and every virtual machine that you're going to be running simultaneously. You need enough storage space to store each virtual machine. And they're probably several gig, maybe up to 100 gig per machine on average. Network speed and latency for centrally hosted virtual machines. Each virtual machine has its own virtual network adapter. It's still going to talk to the network. It's going to have its IP address, although the MAC address is probably going to show up as the same for all of them. That's about the only similarity. Now, you need to patch both virtual machines and physical machines against threats. Viruses attack both. Now, there are some specific VM threats, there are some specific host threats, but you need to generally protect that virtual machine the same as if it was a physical machine. There really isn't any difference in security.